Okay, and yep, and the x-axis. Yeah. Okay. We need to figure out which ones is on top of the other. If we don't want to graph them and we don't want to see what this actually looks like, that is totally fine. Okay. First off, we have our x-axis and we have two functions. Oops. X-axis is also when y equals 0. So let's figure out where each of these intersect with 0. So I should set each equation equal to 0. This is how we're going to get our bounds. Is this the first thing you guys started with? Yes? Okay. Do I need to go through this math? Or can I just say with the... Or do you want to go through it? Do you want me to go fast or do you want me to go slow? Slow? Okay. So let's square root both sides. Then we have 0 equals 4 minus 4x. So let's take out a 4 here. 4 out front, then I have 1 minus x. Okay, and then I get 0 equals 4, and 0 equals 1 minus x. Well, that one is nothing, because those don't equal anything. We have x equals 1. So we know that this graph connects with the x-axis at 1. So we have a point right now at 1, 0. Okay, same thing with the other side. We get 0 equals 4 minus x when I square both sides. So I get x equals 4. So I know that there's a point at 4. Since we're talking about the x-axis, it's at 0. Boom. So we know that cuts it off at 1, 0. I want to graph this so bad, and I'm trying so hard not to, because I visualize this graphing. Okay, there's one more balance that I need to figure out, since we're also doing this along the y. I need to figure out where they intercept. How do I figure out where they both intercept each other? So this was the first one, now we're doing our second one. So we got 4 minus 4x equals our second function, 4 minus x. I'm going to switch this down a little bit. Okay, what do I have to do to both sides? Square them, I get rid of square root, so 4 minus 4x equals 4 minus x. And let's simplify this. I can subtract 4 from both sides, get rid of my 4's, left with negative 4x equals negative x. I don't like my negatives. This would be 3x equals 0. Yes, and that's just x equals 0. Okay, well, I found the x value. What else do I need? Y value. Okay. So I can just plug this into any equation. Let's plug into this one because I feel like it's a little bit easier. Okay, y equals, we want my y value, 4 minus x, which we now know is 0. Yep. So y equals square root of 4, which, yeah, plus or minus 2. And we're talking about above the x-axis, so on the positive y value. So I want 2. Okay. That was just to get the balance without graphing it in any sense. So I have 1, 0, 4, 0, and I got 0, 2. Okay. What did you all do next? After you found no bounds. And we're setting up the integral. What was it? Integral. Okay, let's set it right up. Okay. Do you want to do it by y first? Let's do it by the x-axis first, because it's going to be a little bit easier. Because it's in terms of x to begin with. Okay. Which one is on top of the other in this case? Go 4 minus x minus our other function. So 4 minus 4 x dx. Did we end here? What was our bounds here? From 0 to 1. And then we had, this is the area 1, and then we had area 2. Area 2 is from 1 to 4, and it was just one function. What was our only function here? 4 minus x of dx. Could have done it that way. And then we're going to do what to these two areas? Add them together. Could have also just done it with one area from, well, two areas, from 0 to 4. Could have gone the other way and done the square root of the 4 minus x dx. That one's on top. And then subtracted it by the area underneath it, the integral of the 4 minus 4x of dx, with it from 0 to 1, because it dies off at 1, and this one from 0 to 4. Who did the first way? This side. Took two different areas and added them together. Who did the second way? Which one? Okay, I tell you, the second one is easier. And it's much easier to see it if you graph it. But you can also do it this way. So it connects with the x-axis underneath it. So you only have like a little portion of the graph that you're subtracting from it. Okay. Do we need to go over the integrals for these two? Do you want to? Yeah. Okay, close your eyes. You guys are also quiet. Close your eyes. If you want to go over the integrals, raise your hand. Hands down. If you don't want to do it and want to move on to distant washers, raise your hand. Okay, hands down. Do you want to do this? You can open your eyes now. Do you want to do this, me telling you, or you want to do this up on the boards together? I should have asked us to do the eyes closed. Boards? Okay. Boards, do you want to do half and half? No mind, just do the whole thing. Okay, let's do groups. We're going to count off. We have 12-ish. Oh, Sean's right there. Okay, now we have 13. Let's do, what? We have 13, right? 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh my god, I was like, I swear to God, there's never been 15 of you, ever. Okay. Let's do count up to 4. 1, 2, 3, 4. 1, 2, you're 3. Riley's 4. 1. Yep, you're 4. Yep, okay. Get up in 2 groups. I'll give you a hint. We're gonna have to use U-sub. Oh, U-sub makes it easier. Fine. 1, 2, 3, and 4. Yeah. Yeah, go ahead. And it's just a stepping stone to something a little bit harder, but should be fun.
You plug it with the original.
What's confusing? The calculator is very confusing. I would just like put in 1, put in 0, just do the math. Yeah. I don't like it. Okay, 6.2, we're moving on. We're doing volumes of a solid. What? That is so true. Volumes of a solid. And we're going to revolve them around different axes. So these are going to be solids of revolution. And there's two different methods that we have to use. It's called Dis method and washer. Kalisha, guess which one's going to be easier? Disk and washer method. Guess which one's going to be easier? Disk is going to be easier. Washer, we're going to have a hole in all our shapes, which then we have to do this again. Area between two different curves. Methods. Okay, today's all going to be about disk. Disk is much easier. So today's disk. Disk method. Bless you. So a disk only deals with one curve. Oops, that is so light. only is dealing with one curve. So we take any curve you want. Let's just start with a basic line. We have a line. This is y equals a, whatever it's going to be. We take our bounds. So going from A to B. And what is this shaded region called? Yep, area under a curve. So right now we're only dealing with one curve for disk. So we're putting everything we just learned aside for a moment. So we want this area all underneath. But this is volume. So I need a 3D shape. So we're going to take this area right here, this shape, and we're going to revolve it around the x-axis to begin with. So we're going around the x-axis. That is not a good color for this. Let me pick a different one. Going around the x-axis. I'm going to draw this somewhat nicely, if I can. Around the x. So go down to like where the B is. I do that way too big. Something like that. Going around. So I went behind. Went behind the paper. Went around. Gotta keep going until I make a full cylinder. That was even worse. Okay, guys, I can draw this so much better. Not on Smooth Draw. Right there. Doing the same thing to the other side as well. You good, JJ? Okay. Down below. So I have down here another line that connects it, which is y equals negative a. Which one? That's like my cylinder, so my two sides of my cylinder. So right now I have a cylinder over here. This is kind of a dotted line. As such. Yes, so a straight line, if I revolve it around the x-axis, I'm going behind it, going all the way down. That's half of it, and going all the way back up. I have a cylinder. Can you guys make a cone for me? What graph would make a cone if I revolve it around the x-axis? Yeah, go ahead. Okay. So a straight line makes a cylinder. How would I make a cone? What line would give me a cone if I revolve it around the x-axis? What? Yeah, linear function. So I had something like this. Let's start with just y equals mx plus b. Something like that. This point doesn't really move. It's at the origin. We're not going to revolve it around. But this guy, I can. So go down, I go over. So I'm going in front of the paper and then behind the paper. I'm going to make a cone. As such. So I'm just revolving it around the x-axis. So revolving it around the x-axis. And we have a 3D shape. Okay, how would I make a sphere? Let's do another one. One last one. How do I make a sphere? Try to make a sphere on your paper. What graph would give me a sphere? Right. So revolve it around the x-axis.
Like a half circle. It's like a half circle. Two.
Right, rotate it all the way around.
That's not what I got.
So I'm going to start with half of a shape. What shape do I need to start with for a sphere? A square? If I rotate a square around, I would still get a cylinder. There's no sides or lines in a sphere, so I'm gonna be curvy. Like this. If I do that, I'm kind of gonna get like a football, right? Something like that, where it's like rotated around here. And it's over there. So it's kind of like a football. Yeah? Well, we made a football. That's kind of cool. Looks more like a rugby ball. Try a semicircle. If I do a semicircle. Yeah, circle's the half circle, semicircle. Yep. Let me rotate a semicircle around the x-axis. So rotating it around here. How would you draw that? Into your paper, and then you're back flat with the paper, and then you're coming out of your paper, and coming above. Wait, do I get a sphere from this? Yeah? Yes. So I do the negative, and it kind of comes out of my paper. This is behind. And then it comes out in front of the paper. So I have a sphere now. Okay, we're dealing with these shapes a lot. This is the disc method. I'm just going around, coming back in front of it. If I had a hole in the middle of it, that would be a washer. Okay, any questions about how we rotate around the x-axis? We're going to do the same in a little bit for the y-axis, but not yet. Okay, I'm going to give you a curve. I'm going to start with a random curve that we know not much about. Okay, oops, let's not do that. Yeah. Okay, this is going to be a curve from A to B. I want you to flip that around the x-axis and try to draw a 3D shape. So rotating around the x-axis here. My bounds be from A to B. And that's the area. So I'm going to draw my curve, try to copy it down below, if I can. Then I'm curving behind my paper, back onto my paper, and then in front. I was thinking more like a vase. I feel like it's a vase. Okay. Do we get roughly this weird fat face looking thing? Yeah? Do we get it? What? Oh, yeah. Okay, when we had area under the curve, when we were doing the integral of it, we're chopping it up into what shape? Rectangles. Yep, we had infinitely many rectangles that we're chopping it up in, right? Now we're talking about it in 3D. So we're not kind of chopping up into rectangles anymore. We're chopping it up into little tiny cylinders. Kind of like so. That's the front half of it. So I went right in front of it. And then I also have to go behind it as well. So it's like a very, very small cylinder. Right there. The thickness of the cylinder represents our dx in our integral. So whatever that thickness is. So let's get the formula for this. Let's start with just a cylinder. What is the volume, since we're dealing with volume of a cylinder? What's the equation? Say it again? Yeah. Pi r squared times height. Okay. Height and radius we gotta figure out. Okay, radius. What would our radius have to be of this? So we're talking about from here to here. What am I touching right at this point? Yes, sort of. The height is going to deal with something else. The height would be more like the height of the cylinder right there. We're talking about the radius of just that cylinder. So I'm just going, kind of like flipping it over. I'm trying to find the radius of that cylinder. So I'm starting at 0, and I go out to what point? I go out to that blue line, right? What is that blue line? Yeah, f of x. It's just going to be our function. So this is just going to be our function. Let's call it, trying to figure out, let's call it y for now. Or f of x, whatever one you prefer. Pi is still pi. And on y, we gotta square that, right? Put a square out there. Then, think of that little tiny cylinder. This little slice right now. The height of this is just going to be dx with an integral. Dx, just like the height, the width of all of those rectangles was going to be dx. So now I have dx. So that's the start of my function. I just have to add my integral. So volume equals, from a to b are bounds of pi times our function. But our function, since we're talking about volume, has to be squared. And then dx out front. You might see it with pi on the outside. That's okay. You can obviously put pi on the outside. Pi is just a number. But I promise you, you're going to forget to write pi so many times when doing this formula. So when we think about volume of a sphere, we have pi in it. So when we first start writing it, just put pi inside the integral. Because otherwise you're going to forget to just write pi on the outside. So you might also see it as this. Volume equals pi from a, ooh, that was a bad integral sign. And then we went fat for some reason. Okay, from a to b. Pi can definitely go outside. Of a function, we have to square a function because that's what we do with volume of dx. Okay, let's do an example. There is our function. Let's do an example. Let's do an easy one. Let's find the volume of the solid of revolution generating by revolving it around the x-axis and our function. I hate writing all of this information every single time. I just want to give you the functions by revolving it around y equals square root of x. Let's start with that one. And bounded by x equals 5. Okay, I know we don't like graphing, but we're going to sketch this because it looks nice and we get a lot of information from graphing it. What does y equals the square root of x kind of look like? Show me with your hands. Yeah, it's kind of like half a parabola. So we have a parabola, we're turning it on the side, and we're just taking the positive values of it. So it's going to look something like that. And we're going to stop at x equals 5. So just 5. Okay, revolve that guy around the x-axis. So go down below. Okay, so this was the area of my initial curve. Now I want the volume of this now solid of revolution around the x-axis. Okay. Okay, let's start with the formula. What is my formula that I'm starting with? Yes. Let's plug in some values. What is A? What's B? Yep, I'm going to put pi inside just because I want us to get a little used to that. Pi is inside. What is my f of x? Square root of x. And what do I have to do to that? Square, because we're talking about volume. And then of dx. You guys got this integral. Take the integral and find the volume. Because you're just squaring it. Such bedrock. Just wait until we get to No, I draw washes beautifully, and then on here, I tried to do it today, and it just looks like chaos and mess with all the colors. Okay, so we square square root function. So we're just left with x. Bless you. So we have the integral of x dx. Okay. Do you want me step by step or want to just know the answer? I feel like, yeah, right? Volume equals, what do we get? 25 pi 2. And what's my units? Cubic units or units cubed? Either one. Yes. Good. Oh, I can't scooch down. Okay. Okay, I'm gonna scooch up for a second. Okay, problem up on the boards. Same groups? Okay, I want you to take y equals x cubed. Revolve it around the x-axis. I'm just doing the shorthand. Revolve. Revolve. Okay. Rotate it. Whatever. Rotate it. Revolve around the x-axis. And I'll give you a bounds. Go up in your groups. Try to sketch it on the whiteboards. Can you plug in my values?
Power to account. I can't add them together. I have to multiply them together.
Tomorrow we're good.
Okay.
Write down right. Two to the power of 2 to the power of 2 squared. I don't think you know this. I think you're excellent. The weird part is there's different amount of negative to 0. There you go. We'll try to swim. I agree. So why do we actually write X cubed dot 1.
Okay. We are done for today. Did you guys want homework for area under graphs? I think I forgot to give you. I think that was. Yeah.
Whether you have a physical homework or not, we can probably help all of you. That's right. Doing some problems by choice out of the book because there's hundreds of them. I would encourage guys to
I wrote them down. They disappeared.
Look outside.
I have them. What do you want a revolving homework assignment?
let me know.
Let's try homework. Page 486. Just do 23. Try it. It's a disc. I'm pretty sure. Yeah, I'm pretty sure it's a disc. Yep. Ooh.